Hello and welcome. Today in the last lecture of 7th week, let us discuss about lot of examples that exist in terms of the nature based solutions and have multiple benefits including the climate solutions. So, the concepts what we are going to cover are these 7. So, first we are going to discuss on the mangrove initiatives for shoreline habitat and tangible incomes. So, abbreviated as MISTI. This is a proposal, this is a kind of mission already has been achieved and going on. Then we will see few engineering techniques particularly in the sector of bio. So, bioengineering techniques in Himalaya that are in the principle of nature based solutions are being used as a nature based solution for climate change adaptation and mitigation along with other collateral and multiple benefits. Then we will talk about the constructed wetlands, particularly the microbial fuel cells. Sometimes they are abbreviated as CWMFCs. So, in terms of the water management, let us also discuss about water management, particularly million recharge wells as far as the Bengaluru example is concerned. So, here we will discuss about that how this concept has helped as a test study or as a case study in terms of the Bengaluru city in India, which is located at the south of India. And then coming to the fifth one, we will discuss about the phytoremediating plants and floating wetlands to treat the wastewater. So, wastewater treatment has become a very important problem and concern for all of us. So, how this phytoremediating plants and floating wetlands they help in treating the wastewater. And then coming to another terminology called sponsity. So, what is the idea as far as a sponsity is concerned with respect to the water management. And then we will discuss about the ridge to reef. So, starting from the beginning of this of the water at a means from the ridges and through before reaching the what you say the coast, before reaching the estuary, whatever way it takes or whatever the pathway it takes, how they need to be managed at different parts and particularly with respect to the storm water management we will discuss. So, friends, let us start with an example as far as the MISTI is concerned, as I just spelled out in terms of mangrove initiative for shoreline habitats and tangible income. So, that means it protects the or it is affiliated to the shoreland habitats and also it offers some tangible benefits. So, that means it is in coherence with nature based climate solutions and a kind of international mangrove day and a logo or a kind of brochure first page is shown in terms of a graphics. So, you can see lot of mangroves pictures and one mangrove tree having lot of the root structure also can be very well seen from there. And let us talk about the mangrove restoration, particularly the blue carbon and also with respect to the coastal resilience. So, these mangroves they serve as natural barriers against cyclones. All of us know the erosion, particularly soil erosion and storm surges, and they also strengthen the coastal infrastructure by integrating mangroves with sea dikes. So, whatever the sea dikes we make and if we integrate and this mangroves, then it will strengthen the coastal infrastructure and to reduce the maintenance cost. So, it also reduces the cost of maintenance and also more importantly as far as the climate solution is concerned, it sequesters carbon 2 to 4 times faster than tropical forest. So, example is from Mumbai and with respect to the objectives as far as the MISTI program is concerned, the objectives are to increase the mangrove cover, protect the coastlines, generate about 22.8 million of percentage of employment. So, that means it is also integrated with some other programs as we will see in terms of MG Naregas, so Mahatma Gandhi National Rural Employment Guarantee Scheme. So, it is very important that it generates 22.8 million percentage of employment. So crucial as far as the coastline or the people who are staying or who are habitating around the mangrove areas. And as we already mentioned, it sequesters carbon 2 to 4 times faster than the tropical forest. So it boosts carbon stocks. So implementation led by state forest departments, because as far as India is concerned, our structure is like that. In every state we have a state forest department. So every state forest department, they lead this program. The initiative focuses on community participation, for example, raising nursery plantation and monitoring and promoting ecotourism. Yes, promoting ecotourism is also a part, because as more and more people visit, they will also learn about the positive benefits of mangroves and a kind of attitude towards nature based conservation. The target areas, they focus on areas like Sundarbans, particularly West Bengal and many other areas. So it is as far as Sundarbans is concerned, over 22.5 thousand hectares of land identified for restoration as of late 2025. So coming to the important component of this is the funding. As far as the funding is concerned, the program operates through the convergence of Compensatory Afforestation Fund Management and Planning Authority, more generally known as CAMPA, and the MGNREGS. So under CAMPA and MGNREGS, this particular MISTI programs are being funded. And the background, it is launched in response to the Mangrove Alliance for Climate against the call happened in COP26. So we have the we have the COP26 in Glasgow in 2020, and then in COP27 there was the call for in terms of Mangrove Alliance for Climate. So this is a response to that, towards that, and to promote the green economy. So key focus, the scheme addresses, this MISTI scheme, it addresses the need for a protective bioshield along the coast to mitigate the climate change effects. Now let us talk about some of the bioengineering examples in terms of the Himalayas. So in terms of the bioengineering, so what happens, this involves a soft approach, only plants, and a hard soft approach, that means combination of both plants with materials like bamboo or somewhere little bit related required as far as the steel wires. So grass planting is very good in terms of contour and diagonal. It is used for slope over to reduce runoff. It is used for surface cover to reduce the runoff speed and trap debris, particularly on slopes less than 65 degrees 5 degree. In terms of brush layering, so it involves placing the woody cuttings, particularly the hardwood cuts in horizontal rows along the contour to form a barrier which traps materials and strengthens the soil. So you can see, and if this kind of wood based things are utilized in terms of bioengineering, that is in the principle of nature based climate solutions. Vegetated cliff walls, a structure of bamboo or timber filled with soil inside which plants are placed. As the structure decomposes, the root system takes over, and that is how it creates a lasting anchor. It creates a kind of lasting anchor. So live check dams, large cuttings they are planted across the gullies to catch the debris and thereby reduce the erosion. So now let us move on to implementing challenges and what are the key factors for success. Timing, work should be executed in the dry or pre-monsoon season to allow roots to establish before heavy rain. Site management, proper drainage is critical. If water is not managed, it may cause landslides even on vegetated slopes also. And as far as the maintenance is concerned, the initial protection from the livestock grazing and regular monitoring are essential to prevent the failure of newly planted vegetation. Now, move on to comprehensive planning. It must be combined with proper geological and hydrological investigations to realize maximum goal. So, let us take the example in terms of Nog in the place Nog located in Himachal Pradesh. So, a road formerly closed for months due to landslides was secured using bioengineering, particularly wire mesh and native plants that make it resilient against intense monsoon. So, wherever required little bit of wire fencing, steel wire fencing utility is also required. And then in Nepal, particularly the Chitwan and Makwanpur, use of bamboo based engineering in stream banks and road slopes reduce the landslide incidents and provided further strengthening community resilience. So, bioengineering is not a standalone solution for massive deep seated slides, but for slope erosion and shallow failures, that is the depth is has to be little less than 3 meter. So, it is a superior, sustainable and cost effective alternative, particularly for our Himalayan mountain terrains. Now, on the left hand side we can see the along the slope the distribution in terms of the soil removal work on top, followed by little down you have the horizontal drainage boring, then the drainage well. So, some of the water is also being taken off from there, so that it reduces the pressure on that, and then the drainage funnel work you see from there also it is taken down below and directly emptied to the nearby water channel, or you say the river outlet. So, on the left hand side you have the protective forest and the gabions and the plant roots you can see towards the end, and the rock filling little bit on the both side of the water channel, or you say the river channel, and down below you have the check dam. So, this is the what you say combined and superior, sustainable and cost effective alternative in terms of the bioengineering, which is practiced which are being practiced very efficiently in the Himalayas, as mentioned in terms of Nepal and in terms of the Himachal Pradesh. Now, friends, let us move on to the constructed wetland microbial fuel cells. So, we have the abbreviation as CWMFCs. So, these are hybrid eco-friendly systems combining engineered wetlands using the plant microbes for wasteland treatment, particularly the wastewater, and with the microbial fuel cells this allow simultaneous organic pollution removal up to 80 to 20% of COD. So, this much of removal of COD is a very high amount, and what are the advantage? If you can see on the right hand side, you have the representation of major components as far as the wetland microbial fuel cells are concerned, plants on top, and this side you have the registers. On the right hand side you can see the media and the inlet is down below, and on the left hand side you have the electrodes in terms of cathode and anode, and you have the outlet also there. So, this is a typical representation of the major components of this constructed wetland microbial fuel cells. The advantage at this, particularly they are effective in removing the suspended solids, organic matter and pollutants with chemical oxygen demand, or you say the COD removal rates often exceeding, as I said, 80 to 100%. So, the advantage is it reduces the greenhouse gas emissions compared to traditional wetlands, suitable for decentralized small scale wastewater management, and it is also being practiced in the principle of nature based solution in many places. Now, let us move on to the next example as far as the water management is concerned. The typical name is Million Recharge Wells, and coming from the city of Bengaluru in the south of India. On the left hand side, the graphics in terms of at different cities that that flood during monsoons in past 3 years, and the condition is really too much alarming. So, if you see what is the concept of water management in the principle of million recharge wells and the sponge cities. So sponge cities particularly, the idea is implementing porous pavements. So, porous pavements, that means they will allow percolation. Rain gardens, so they will also allow percolation. And also rejuvenation of lake ponds to manage the storm water. They will reduce the flooding during the monsoon or during the rainfall time immediately, and recharge, and thereby recharge as seen in the projects, particularly in the million recharge wells. This is really important, we all know that, but it is now being practiced in terms of million recharge wells and sponge cities, and one of the examples is in Bengaluru. And coming to the mechanism, these wells collect runoff from roofs and open spaces, channeling it into ground, thus mitigating flooding while enhancing the water table. Impact: this approach aims to restore the natural hydrological balance, reducing reliance on tanker water and thereby improving the water sustainability. So, this helps in terms of managing the cities in the principle of nature based climate solutions. Now, in continuation, these sponge cities, what they do actually, they manage the urban stormwater and recharge the groundwater by mimicking nature hydrology. So, the point is important, they mimic the nature hydrology using porous pavements, rain gardens and lake rejuvenation, and a typical schematic diagram is shown on the upper right side. So, porous permeable pavements, particularly roadways, sidewalks and parking lots that allow rainwater to percolate into ground instead of flowing into overloaded storm drains. The rain gardens and bio wastes, so landscaped shallow depressions containing water loving vegetables that absorb, filter and cleans the storm water runoff before it enters the ground water. Rejuvenating lakes and ponds, restoring natural water bodies to increase water retention capacity and prevent flooding. Constructed wetlands, particularly engineered areas designed to treat and store water, reducing the pollution. Green roofs and walls, yes, vegetation on building that absorbs rainwater and reduces the urban heat island effect. So, together all this in cumulation in a cumulative way, they contribute towards a sponge city in the principle of nature based climate solutions. Now, let us move on to the next one in terms of phytoremediating plants and floating wetlands to treat wastewater in terms of nature based solutions. On the left hand side, you can see the plants and bacteria in pollutant removal process in floating wetlands. So, the schematic things what is mentioned, you mention a kind of floating wetlands. So, in terms of mechanisms of pollutants removal by plants, sedimentation, adsorption, phytovolatilization, physical entrapment of pollutants in roots, stabilization, phytodegradation, filtration, providence of environment for microbial proliferation and uptake of nutrients. So, what happens, the phytoremediation and floating treatment of wetlands in terms of FTWs represent the sustainable nature based and cost effective wastewater management solutions that utilize plants and their associated microbial communities to treat water, remove heavy metals and reduce the pollutants. This is being practiced, and this also very well serves or fall under the nature based climate solutions having multiple benefits along with the climate. These systems act as biological filters with plant roots extending into contaminated water to absorb nutrients and create habitats for beneficial organisms that degrade organic contaminants. So, you can see on at the middle there are, if say the upper right of the figure, a close up of the root and associated bacteria is shown, particularly the endophytic and rhizospheric. So, endophytic bacteria present inside the plant tissues, whether the rhizophoribacteria they are present on the surface. So, that is how the mechanism of pollutant removal by microbes happen in terms of degradation of pollutants and promote the plant growth. So, this is very well practiced and helps in terms of treating the wastewater coming from the cities and habitations, and that is how it falls under the nature based solutions in terms of addressing the climate. So, phytoremediating plants, floating wetlands and rhizosphere microbes. What are the advantages? The advantages are it is cost effective, as we understand, low tech and lower cost compared to conventional mechanical treatment plants. Sustainability, yes, low energy inputs, often solar driven, and minimal sludge generation. Adaptability, floating rafts can rise and fall with fluctuating water level. So, it is well adapted in terms of the fluctuating water levels. And coming to importantly the ecological benefits, it enhances biodiversity, improves the aesthetics and provides habitat for bird and fish, apart from what you say remediating in terms of the wetlands to treat the wastewater. Now, let us move to a total solution concept in terms of the ridge to reef prospects for natural flood risk management in biodiverse South Asia. So, let us see as the graphics goes, it is split into 4 parts. The first part is managing headwaters as sponges. Second part, conserving and restoring the river width and floodplain connectivity. Third is blue-green infrastructure in urban areas. Fourth is maintaining and creating space for water in fluvial coastal settings. So, first you can see in terms of first one, headwater drainage management, runoff in terms of attenuation features, and you can see the offline storage and cross slope woodland management. Coming to the second one in terms of conserving and restoring the river width and flood plain connectivity, soil and the land management, the floodplain, particularly the woodlands, floodplain woodlands, catchment woodlands, river restoration and a kind of online storage ponds. Now, moving on to the third one is in terms of the blue-green infrastructure in urban areas. We can have the pocket parks, bioremediation ponds, green roofs, or you can see the removal or setback of bank structures at towards the end when it is going towards the meeting the estuary. The maintaining and creating space for water in fluvial coastal settings. So, seagrass planting, mangrove reforestation, artificial reefs and brushwood barriers, appropriate land use zoning, or you say the relocation of vulnerable communities. Now, friends, in terms of storm water management, so what are the key components? In terms of the key components, the first is this is a kind of nature based solutions. They reduce the storm water runoff up to 80%, filtering the pollutants and reducing the road flood risks, making them essential for sustainable urban particularly flood prone and low traffic areas. So, what are the key components mechanisms? As you understand, the vegetated swales, or sometimes we call the bioswales. So, what are they? They are the shallow landscaped channels with grass, crops and trees that slow down, filter and encourage infiltration of water, reducing peak flow during heavy rain. And coming to the permeable pavements, PPS, special load bearing surfaces, porous asphalt and concrete or pavers that allow the water to seep through into the underlying stone reservoirs, storing or filtering it before it enters the soil. And the green infrastructure we all know. Now, what are the benefits? Benefits for the road infrastructure and monsoons. Let us see. In terms of the first one, the flood reduction. Yes, by absorbing up to 80% of the rainfall permeable systems cut the volume of runoff. So, we need to cut the volume of runoff because we have to have the permeability system as far as the absorption and storage within the system is concerned. And then coming to the improvement in terms of water quality, the vegetation and soil filters trap pollutants, oils and metals from road surfaces. The urban heat reduction, permeable surfaces, those with vegetation help mitigate the urban heat island effects. And the fourth one is the groundwater recharge. So, water is returned to the soil rather than being directed into storm drain. So, these are the storm management options in the principle of nature based solutions. So, friends, to discuss this, we have taken the reference from this UNEP and other resources which are available here and there. Now, in terms of discussing this, to conclude, so we discussed that mangrove initiatives for shoreline habitats and tangible income. So, it gives lot of what you say earning, or you say the employment to the people who are habited along the shoreline, and through the ecotourism tourism prospect, it serves in letting know many people or tourists, they come and visit these places. So, they come out, they know the importance of the mangroves in protecting the shorelines, in arresting the storm surges, and also arresting or reducing the soil erosion. So, in many ways it serves several purposes, and also complies to COP27 in terms of the Mangrove Global Alliance call. And then coming to the bioengineering in terms of the Himalayas, yes, we discussed that we found that integration of the blue integration of the green infrastructure along with some gray or the steel materials, we can very well arrest the landslides in terms of heavy slope areas such as we found in Himalayas. And also we discussed about the sponge cities and the million recharge wells as a case study as far as the Bengaluru is concerned. We also discussed the reach to reef in terms of the flood management, in terms of managing the total system. So, in a watershed concept. So, these all serve in the principle of nature based solutions towards climate mitigation and adaptation, along with giving lot of collateral benefits or multiple benefits to various what you say sectors. So, thank you very much for listening to this particular talk and talk of this week, which is on the nature based solutions and nature based solutions for climate mitigation and adaptation. So, this particular 7th week is very important and unique, because learning this will help us understanding that how the solution for climate change adaptation and mitigation lies in nature only. Thank you very much.